Okay, we're going to go over the end of chapter problems for chapter 4. 4.2. An investor buys a bond for $10,000. The bond pays $200 interest every 6 months. After 18 months, the investor sells the bond for $9,500. What type of income or loss did they have? Well, it's 1.5 years. Cash, he got $200 3 times, $600. He had a capital loss. He sold for $95,000. He bought for $10,000, so he lost $500. So overall, his holding period return was $100. Problem 3. Assume you purchased a share of stock in Verizon Communications at the beginning of 2017 for $54.58. A year later, the stock was worth $53.53, but during the year it paid a $2.32 dividend. What was your income? $232. That's all the cash you got. Capital gain or loss? You lost money. You bought it for $54.58. You sold it for $53.53. Total return, the sum of those two, $1.27. Total return percentage, $1.27 divided by $54.58, what you paid for it. Okay, number 7. Given a real rate of interest of 2%, an expected inflation premium of 3%, risk premium for investments A and B of 4% and 6% respectively, what's the risk-free rate of return? It's the real return, R asterisk, plus the inflation premium, 2 plus 3, 5%. What's the required return for investment A and B? It's the risk-free rate plus 4, and then the risk-free rate plus 6. Okay? Assume you invest $3,500 today in an investment that promises to return $7,700 in exactly 10 years. What's the internal rate of return? You're going to invest $3,500, you're going to get $77,000, nothing in between, 10 years. IRR 8.2. If your minimum annual return required is 9%, would you recommend it? No. Number 16. You're evaluating 5 different investments, all of which involve an upfront outlay of cash. Each investment will provide a single cash payment back to you in the future. Details as shown. Calculate the IRR of each investment. State your answer to the nearest basis point. Okay. Initial investment, future value, years. Present value, future value, payment is 0, N. Solve. And this one is solved right there. Make sure you're comfortable doing those. 17. Kate Berry will not invest unless she can earn at least an 8% return. She's evaluating an investment opportunity that requires an initial outlay of $2,500 and promises to return $5,000 in 8 years. What's the internal rate of return? There it is, 9.05. There it is in the Excel function. There's how you'd set it up in your calculator. She's going to invest $2,500, nothing in between. She's going to get $5,000 after 8 years, 9.05. Should she do it? She requires at least an 8% return? Yes, she should do it. Okay, 4.18. Use financial calculator or an Excel spreadsheet to estimate the internal rate of return for each of the following investments. In your calculator, put these in the cash flow worksheet, hit IRR. Number 20. Assume that an investment generates the following income stream and can be purchased at the beginning of 2020 for $2,000 and sold at the end of 2026 for $2,200. Estimate the IRR for this investment if a minimum return of 5% is required. Would you recommend this investment? Minimum 5%? IRR is 5.42. Yes. Shows in the table. You buy it for that. You get all of those incomes. This is the sell price plus the income for the 2026. Okay? And here is number 24. Let me make it a little smaller so I can get it all on the screen if I can. Well, I'm going to, there we go. Number 24. The historical returns for 2 investments, A and B, are summarized in the following table, 2016 to 2020. On the basis of a review of the return data, which investment appears to be more risky and why? Okay, there's investment A. Average return 12% for both of them, A and B. Deviation squared. Remember now, this is historical data. So you're going to sum those up and divide by 4 over 5 years of data, N minus 1. Take the square root of that. That's the risk. Coefficient of variation, standard deviation divided by expected return. So standard deviation is 10.42, coefficient of variation 0.87. For B, standard deviation is 3.16, coefficient of variation is 0.26. Clearly B is a lot less risky than A. There's your formula for standard deviation of historical returns. Okay, let's look at the problems from the Chapter 4 appendix. Number 3, for each of the following initial investment amounts, calculate the future value at the end of the investment period if interest compounds annually. These are just an exercise for you to make sure you're comfortable with your calculator. Here's how you set up the first one. N is 20, interest rate is 5, present value is $200. You're investing it. What's it going to be? These are lump sums. Number 8 says, the following table lists the lump sum payout, the timing of that payout, and the discount rate associated with 5 different investments. What's the present value of each investment? Same setup. You're given N, IY, the payment, and the future value. You compute present value, and here's the first one set up so you see the pattern. Again, practice for you. Number 13 says, consider the streams of income given in the following table. Find the present value of each income stream using a 1% discount rate, then repeat those using an 8% discount rate. Compare the present values and discuss them in the light of the fact that the undisclosed income amounts totals to $10,000 in each case. Note that investment B is hit much harder by the change than investment A, since more of investment B comes further in the future. The higher the rate you could invest it for right now, the less it's worth. 15A. Congratulations, you just won the lottery. Would you rather have $80 million spread out in 20 equal annual payments of $4 million, with the first payment coming 1 year from now, or $60 million as a lump sum today? Assume a 3.5% discount rate. 3.5, 4 million, 56 versus 60 million today. Take the 60 million today. Terry Alessandro has an opportunity to make any of the following investments. The purchase price, the lump sum future value, and the year of receipt are given below for each investment. Terry can earn a 10% rate of return on investments similar to those currently under consideration. Evaluate each investment to determine whether it is satisfactory and make an investment recommendation. She wants 10%. You're solving for the internal rate of return. So A and C are good, B and D are not. And 19. You purchased a car using some cash and borrowing $25,000 for 50 months at 6% a year. Calculate the monthly payment. That's a number of months. They told you that right there, 50 months. The rate, remember, it's got to be a monthly rate. So it's 6% divided by 12. You borrowed $25,000, so you got that. That's positive. You're paying it down to 0. So the payment is $566.34. Now the appendix problems for sure were just to review you on time value of money. If any of this was unfamiliar, you had any problem working any of these, go back and look at some of the tutorials. Go back through them. There's a whole bunch of them posted out there to help you with this.